Today we're going to be talking about Pythagorean Theorem and ways you can use Pythagorean Theorem. Hopefully you're familiar with this. So one way you can use Pythagorean Theorem is to find missing side lengths of a right triangle. So Pythagorean Theorem only works for a right triangle. Pythagorean Theorem is also, it's a relationship among the three sides of the right triangle. The relationship is that the square of the hypotenuse, and remember the hypotenuse is always the longest leg of the right triangle. The hypotenuse is always the side that is opposite from your right angle. So if here's your right angle, the side opposite from it is your hypotenuse. And the hypotenuse always gets the letter C. Now the relationship is that the square of that hypotenuse is equal to the sum of the square of the other two sides, which we refer to as the legs. And the legs are side A and side B, and it doesn't matter which one is which because they're both legs. So this could be A and B or B and A. It doesn't matter. The main focus or the main thing you don't forget is that the hypotenuse must be the C. Because in our equation, so what the relationship says there is that when we take the sum of the square of the legs, okay, it equals the sum of the square, equals the square of the hypotenuse. So that is your Pythagorean theorem. A squared plus B squared equals C squared. Now what you probably don't realize is that you can use Pythagorean theorem to solve everyday problems, as well as solve problems where it's just asking you to find the missing side. So basically, if you place a 16-foot ladder 6 feet away from the house, will you be able to get onto a roof 20 feet tall? One thing that helps us in situations where we're dealing with everyday real-life problems is to remember that heights are always perpendicular to the ground. And the reason that's important now to mention is because if it's perpendicular to the ground, well, perpendicular implies that you have a right angle. And therefore, then we can create a right triangle, and then therefore we can use Pythagorean theorem. So in this situation, if we start with a right triangle, and we kind of label our pieces. Well, okay, we're gonna lean a ladder against a house. So a ladder, when you have a ladder, it's usually the diagonal, because if you're trying to go up a ladder, it's not straight up and down. It is leaning against the wall diagonally. When we see an example here about 6 feet from, so this whole 6 feet from a house, if you see about 6 feet from or something that says away from, that's always going to be your ground or the horizontal distance. Also, okay, can we get onto a roof 20 feet tall? Any about tall? Tall is height. So think about when you measure how tall you are, you're measuring from the ground up. So this over here, on this side, this is going to be where the house is, because we're wondering, okay, well, if that roof is 20 feet tall, is the ladder going to reach up? Well, if we say, okay, here's our right triangle. We know the ladder's 16 feet tall. We know it's 6 feet away from the house. Can we reach to the top of the house? So here's your situation where it is a real life, everyday problem, but also you can find a missing side length of a right triangle. So if we didn't know anything about the word problem, we could still find the missing side here of this right triangle using Pythagorean theorem. It's always a good idea to label the sides. Remember, A and B, it doesn't matter which one is which. The hypotenuse must be C. And again, the hypotenuse is the side opposite from the 90-degree angle. So you start with your Pythagorean theorem, and you plug in your pieces. So A is your x, so x squared plus b, and this problem is 6, and your hypotenuse is 16. So x squared is going to stay x squared. 6 squared is 36, and 16 squared is 256. So you're just going to go through and keep solving for x. So subtract 36 from each side. So you're left with x squared is equal to 220. Now you never leave an x squared. Remember, we just want to solve for x. So x squared and x are two different things. So to get rid of a squared, you have to take the square root. So that leaves you with x is approximately 14.83. So your height here is 14.83. So your ladder, if you have a ladder 16 feet tall and it's 6 feet away, it's only going to reach up about 14.83 feet. So no, you're not going to be able to reach, can't reach 20 feet up. All right, because you can only reach 14.83 up. Now, another use for Pythagorean theorem is that we can use it to classify triangles by their angles. So, when we use Pythagorean theorem and when we work it all out, if the hypotenuse squared is equal to the sum of the legs squared, then it is 100% a right triangle. If, when you do this equation and your hypotenuse is less than the sum of the square of the legs, then you have an acute triangle. And on the other side, if your hypotenuse is bigger than the sum of the square of the legs, then you're going to have an obtuse triangle. So I want you to also remember that side angle relationship that we talked about last time. Remember that side angle relationship in triangles. The bigger the side, the larger the angle is. So this kind of makes sense if you understand that side angle relationship. Because if this side here, which happens to be the C, is small, then the angle across from it is also going to be small. If the side is bigger than the other two, then obviously that angle across from is going to have to be bigger. So again, that side angle relationship plays a huge role here. Okay, so let's use that, let's apply it and classify the following triangles by angles. So when you're looking at a triangle, since we don't know if it's a right triangle, we technically don't have an hypotenuse. But what we're going to do, since we don't know which one is the hypotenuse, is we know the hypotenuse is always the longest side. So we're going to identify the largest side and say, okay, that's going to be my C. So then I'm going to test out the Pythagorean theorem, and this is how I write it. I say, okay, if I take C squared, does that equal the sum of the square of the legs? So you test that out. 29 squared is 841. You want to know, well, how does that really compare to the sum of the square of the legs? Well, that is 832. So you can see there that the hypotenuse is greater than the sum of the legs. So if the hypotenuse is larger, if the C is larger, that means the angle across from it is larger than 90. So this triangle is obtuse. And again, these pictures are just there to kind of guide you. It's not that it's exactly drawn to scale. You have to use the numbers. The numbers are going to give you your answer. All right, in number 2, we have sides of 6, 9, and 3 square roots of 13. What? What the heck is 3 square roots of 13? Remember, you have a calculator. It can turn that into a number for you that you're more comfortable with. So if you put 3 square roots of 13 into that awesome yellow calculator you have, and you hit the enter button, that's going to tell you that it's approximately 10.8. And you're saying, well, why do I care if that's 10.8? Well, remember, you have to know which one of these sides is the longest before you can start plugging everything in. So therefore, this is your longest side. So when you're plugging things in, you just want to forget about the decimal version and you want to keep it in the exact form. So you're going to actually square 3 square roots of 13. And you're thinking, I am? What? Yes, you have a calculator, remember? It's not scary. So you're saying, does that equal the sum of the square of the legs? So I'm going to type in parentheses, 3 square roots of 13. Close it, then square it. Hit enter. That's 117. How does that compare to 6 squared plus 9 squared? This side is 117. Well, lo and behold, they are equal. So when the sum of the two sides is equal, then you have a right triangle, right? Because that was the whole idea behind the Pythagorean Theorem, that the hypotenuse squared is equal to the sum of the legs. All right, number 3, we have 6, 7, and 8. So again, no matter what order this list is in, if it said 8, 7, 6, we're going to make sure that the largest one is our C. So no matter what order your list is in. So how does this compare to, is it equal to, how does it compare to 7 squared plus 6 squared? Well, 8 squared is 64. Okay, well, how does that compare to 7 squared plus 6 squared? This is 85. Well, you can see there that the hypotenuse, the C, really it's not the hypotenuse, it's just the C side, is less than the sum of the legs. So if this side is smaller, that means the angle opposite from it is smaller than 90. So therefore, this one is going to form an acute triangle. Phew, all right, so now Pythagorean triples. So you're sitting here saying, isn't there anything easier I can do? Don't you have a shortcut? Because we all love shortcuts. I have one for you. A Pythagorean triple is a set of positive integers. I know your eyes just crossed. Positive integers. Integers are just your whole numbers right now. So your positive whole numbers. Okay? Don't freak out. All right. And they fit the rule that a squared plus b squared does indeed equal c squared. So triples are sets of positive integers that follow this rule. Well, this rule gives you a right triangle. Okay? So there are a set of numbers, positive numbers, that will always give you a right triangle. So the most famous and the smallest one is the 3, 4, 5. So let's check it out. If I square 3 and I square 4, does that equal 5 squared? This is 9 plus 16 and 25. 9 plus, look at there. Yes, that is. So a triple is a set of 3 numbers, obviously triple, 3 numbers, that when you stick it in a squared plus b squared equals c squared, they do indeed equal one another. So 3 numbers that was always going to form a right triangle is called a Pythagorean triple. There are some other ones that are commonly used, so it kind of makes a little rhyme if you say 3, 4, 5, 7, 24, 25, 5, 12, 13, and 8, 15, 17. But there are so many more. You can find more, but the simplest way to find more is to scale them up. So by scaling them, if we look at this example, and we're going to scale 3, 4, 5 by 2, it will give us 6, 8, 10. So when I'm talking about scaling, I'm just talking about you need to multiply each side by the same number. So if you scaled 5, 12, 13 by 3, then we would have 15, 36, 39. And no matter what number you scale them by, it will still always give you a Pythagorean triple. So 6, 8, 10 is still going to fall into this rule here that they equal one another. 15, 36, 39, same thing. 15 squared plus 36 squared will equal 39 squared. I'm telling you now, to make your whole rest of the year in geometry easier, is that you need to memorize these. It will make your life a whole lot easier. So you want to memorize the most common ones. 3, 4, 5, 7, 24, 25, 5, 12, 13, 8, 15, 17, and any multiples of. So like if I multiply this one by 2, it'd be 16, 30, 34. Memorize them now.